Hello, good morning, good afternoon, good evening, depending on where you are watching me from. And this video will be talking about heat flow equation, one-dimensional heat flow equation. We are going to use separation of variable techniques to obtain this equation. But before we do so, let's just pray to our God for retentive memory and more understanding. We are in prayers for 2 seconds. Amen. Yeah, prayer is necessary. Okay. If today is your first time meeting me here, amen, go to Google, type Remjack math, amen. You will see a lot of solved mathematical problems. Not only solved mathematical problems, you will also see comprehensive mathematics lecture note for those who are preparing for WAEC, NECO, JAMB, ND, HND, BSc, Masters up to PhD. You will see your lecture notes there. It will do you good. Make sure don't just watch this video. You subscribe to my YouTube channel, share it with your friends. Thank you and God bless you. Okay, yeah, today we'll be looking at this idiot. It's simple as ABC. I'm going to break it down for you to understand. Is that clear? Yeah. This is one-dimensional heat flow equation solved using separation of variable techniques. Amen. Yeah. Yeah. Don't mind my daughter. Whenever I'm solving mathematics, she want to solve maths with her father. Yeah. That is mathematics for you. I don't know whether she want to be a mathematician. Who knows? It's okay. Yeah. So, as I was saying, yeah, I have money. Okay. Sorry for the break in transmission. That is child for you. Okay. Yeah. Here, the heat flow equation is given as partial U all over partial T is equals to C square partial square U all over partial S square. We first write solution, amen, solution, then partial U all over partial T will now be equals to C square partial square U all over partial X square. Then we now assume this, it will be a solution to this particular problem. We now say let amen, let U of X, since the heat equation has to do with two functions, two of us. We have T, we have X here. So U of X comma T be equals to X of X, amen, times T of T. This X is a function of X, T also is a function of X. So let's label this on equation 1, label this on equation 2. So at this point, we are going to differentiate equation 2 with respect to X. But note that X differentiated twice partially. So we are going to differentiate equation 2 partially with respect to X twice. Then the same equation 2 partially with respect to T once. Okay? Let's write differentiating, amen, differentiating equation 2 partially, amen, with respect to X twice and with respect to T once. Okay? So if you agree with me, It means let's differentiate the left hand side of equation 2 and the right hand side of the equation 2 respectively to x. If we differentiate it this way, we are going to have partial u all over partial x will now be equals to, since we are differentiating with respect to x, this t of t will be constant. So t of t will be constant, partial x of x, if possible, then partial x, small letter x. Assume this one to be equation 3. Then since here is what? We are going to differentiate it twice, two of us, according to this. So partial square u all over partial x square will now be equals to t of t partial square x of x all over partial x square. Assume this one to be 4. Then after that we differentiate with respect to t once, partially, two of us. So the same way, but the t will be once. So partial u all over partial t will now be equals to s of x of x will be constant, x of x will be constant, partial t of t all over partial t. Assume this one to be 5. Amen. Okay. So now the reason why we are doing all these ones is we want to resolve this equation 1 excuse me, into two differential equation, where at the end of the day we'll be able to obtain our u. That is what we are trying to do. Okay. So if you agree with me, amen, please, if you have any question, drop it on the comment section. If you agree with me, it means we'll substitute equation 4 and 5 into equation 1. Substituting, amen, substituting equation 4 and 5 into equation 1. Do you agree with me? So if you agree with me, it means anywhere you see partial u, partial t, you write this idiot. So x of x partial t of t all over partial t will now be equals to c squared. C is a constant. If you assume c squared to be equals to 1, it means c will not exist, c squared will not exist here. But if you want to solve together with c squared, no problem. Whichever way you want to do it, it's okay. So, excuse me. So here will now be, yes, equation 4. T of t partial square x of x all over partial x square. This is equation 6. Amen. So far so good. Amen. Okay. Any question? If you have any question, don't hesitate to drop it on the comment section. Look at it and get back to you. Okay. So at this point, we are going to separate the variables. You discover that the left hand side we have x of x partial t of t. Then the right hand side we have t of t partial x partial square x of x all over partial x square. Two of us. So we have to separate the variable. How can we separate it? For us to divide 2 by x of x and t of t both sides. Let's write it here. Divide 2, amen, by x of x and t of t. So if you agree with me, here will now be x of x partial t, partial t of t all over, partial t. Then divide x of x, then t of t. The same thing applicable, equals to, amen, c square t of t partial square x of x all over, amen, x of x square, then all over x of x, then times t of t, amen. Okay, we can now name this equation 7. Yeah, amen. Yeah. Okay. So if you can see what I am saying, this and this will cancel, this and this will cancel. So here will now be, the left hand side will now be 1 all over t of t, amen. Then it's not necessary you put of t. It is not necessary. Let's let go of t. Then partial t of t, amen. Then all over partial t is equals to c square all over x of x, then partial square x of x all over partial x, amen. Then yeah, it's not necessary. It's not necessary. Then we assume this one to be equation 8, amen. So as it is, yeah, you want to solve mathematics? Don't mind my daughter. She likes solving mathematics. Okay? Yeah. Go and cover it. Take. Thank you. Okay. Yeah. If as it is, this that is, the left hand side is equals to 0, the right hand side is equals to 0. So for that purpose, there will be a constant called k. Is that clear? So for this reason, equation 8 will now give us two differential equations. This is equals to k, this is equals to k. So we now have 1 all over t dt of t all over dt will now be equals to what? K. And amen. Okay. And c square of x d square x of x all over d square x square will now be equals to k. So at this point, amen, we'll cross multiply this, yeah. If we cross multiply, we are going to have the left hand side. Let us consider this first, this equation first. So we will have 1 all over t dt of t will now be equals to k dt. Let us just then if we cross multiply, we are going to have this one we are going to have c square d square x of x all over the x square will now be x times k, kx. Then at this point we are going to integrate both sides of this equation. So if we integrate both sides, we are going to have it this way. Here will now be 1 all over t dt. It's not necessary we put t again. It's not necessary. T of t. It is not necessary. Then here will now be equals to integral k dt. Yeah. So here we make this side to be equals to 0, or we also divide through by c squared. If we divide through by c squared, we are going to have d square x. It is not necessary we write x again. The x square will now be the x all over c square. What I told you, it is not necessary. If we make it to be 1, it means it will just be like this. It's not necessary you carry it along. But what if here is 3? Assuming instead of c square, instead of this is 3. So for the purpose of this, I'm carrying it along so that if you come across it, something like this, you won't be confused. Okay, so here we are going to, if we integrate 1 all over t dt, we are going to have what? In t, true or false? In t will now be equals to integrate this, we will have what? We will have kt plus c1. So if we want to make t the subject of the formula, we take log on both sides. Take log on both sides. Amen. If we take log on both sides, we are going to left with t will now be equals to exponential kt plus c1. Amen. Plus c1. Yeah. Then let us consider this other equation. Mind you, I told you that equation 8 will give us 2 differential equations, and that is what I'm trying to do here. We are able to look at it here. We are able to consider this one. Then let us consider this other one to have d square x of the x square. This one crosses the sign of equality, becomes minus kx all over c square equals to 0. So how can we obtain this? This is a second order differential equation, true or false? So we now say since we are dealing with x be equals to exponential mx. So if we differentiate this with respect to x, x prime is equals to m exponential mx, then x prime is going to give us m square exponential mx. True or false? So we now substitute this into this equation. So if you can see what I am saying, here will now be mx exponential m square, exponential mx minus minus x is equal to this. Let's do it this way: k all over c square. Your x is exponential mx equals to what? 0. True or false? Okay. So can I clean this up parts? I want to clean this up parts. Amen. Okay. Let me clean this up parts. Okay. Yeah. So if you agree with me, not be so. Now so, if you agree with me, here what is common on the left hand side? You factor it out. Exponential mx is common. Exponential mx, factor it out. We are going to have m square minus 1 all over c square k, true or false? Then equals to 0. True or false? So Here will now be if exponential x not equals to 0, it means our m square minus 1 all over c square k is equals to 0. So we are going to look for, can I clean this part? Or we'll look for m1 and m2. So let's look for m1 and m2. It means to make m the subject of the formula, equate it to this crosses the sign of equality becomes what? 1 all over c square k, isn't it? So you square both sides. If we square both sides, we are going to have m is equals to the plus or minus square root of a all over c square, isn't it? True or false? Amen? Okay? Yeah. Please let us not forget this equation 2, because we will use it. Let me just write it down here. We will use it. U of x comma t, amen, is equals to x of x times t of t. Yeah. Okay. So far so good. If you can see what I am saying, because of this plus or minus, it means this one will give us 1. But in short, if we have something of this one, this is the same thing as what? Square root of k all over square root of c. True or false? So I want to do something. So what if I write this way? Our m is equals to plus or minus square root of k all over c, because the square root of this will now cancel. True or false? It will now cancel. So our m1 will now be equals to plus square root of k all over c, and m2 will now be equals to minus square root of k all over c. Okay? So far so good, amen. So our second differential equation, that is our x of x, x, then put it like this one too. X of x will now be equals to, since this one we got c1, so let's make it c2 exponential m1, which is what? Square root of k all over c x. Supposing you do not put c, I know that this is how it's supposed to be, but you are still right. Is that clear? Since c is a constant, plus c3 exponential minus square root of k all over c close bracket of x. So far so good. The final answer to this particular problem, it means we name this equation, let us name equation 9, then we name this one equation 10. So we are going to substitute equation 10. Remember, this is equation 2, right? We will substitute equation 10, amen, into equation 9 and 10 into, let me do it this way, into equation 2. So if we do that, it means our u, or u of x comma t, will now be equals to our x of x is this, times our t of t. T of t is what? Oh, sorry, not this one. Is this one. Make this one equation 9. T of t is what? This. So we multiply. That is C2 exponential square root of k all over c close bracket x plus C3 exponential minus square root of k all over c open bracket x close bracket, okay, this is equals to times t of t, which is what? Exponential kt plus c1. Yeah, so this is your final answer, and this is what they want from you. So please, in case you have any question, don't forget to drop it on the comment section. I'll look at it and get back to you. Make sure you share this video. Thank you and God bless you. Bye.